Hello friends of Sudoku and welcome to the May 16, 2023 edition of the New York Times Hard Sudoku. Let's just get started. Let's see what we have. Nothing too obvious yet. Well, yes, of course, a 6 blocks down and 1 blocks up, so here's a 6. At least we got the first digit. A 3 must go here or here, and therefore down here, let's see, the 3 blocks up, the 3 blocks over, 3 goes here or here, blocking down. This 3 blocks down, this blocks over, here's the 3. Seven, 8, and 9 in these squares now. Three, 5, 7, and a 9 across here. There's a 3, 7, and a 9 blocking this square, which therefore must be a 5. And therefore a 7 must go either here or here, and a 9 must go either here or here. Let's see the beginning of perhaps a pair, the 4 and a 9 block here, and we've got a 4 and a 9 blocking here. And across here we need to find a 1, 2, 3, 6, and a 9. It's a 2, 9 here, and a 3, so this is a 1 or a 6. There's a 2, 3, and a 9 here. So a 1 and a 6 here, and a 1 and a 6 here, as far as I can. Let me just make sure that these can't be anything but 1s and 6s. They cannot be a 2, nor a 3 or 4. They could be a 5. Oh yeah, they could be a 5. But not here, though. I'll have to work more on the 5s, I think. Nice try. No cigars so far. I will have to get back to that, I think. But we do have a 4 and an 8 here, don't we? So these two squares must be a 4 and an 8, and this 4 makes this an 8, and this a 4. And look at this. We got a 3, 7, 8 here, don't we? And we got a 3, 7, 8 here. So these 3 squares must be a 3, 7, and an 8. Does that mean anything for the rest of the puzzle? I don't know. I'm not sure, because there are still 4 empty squares here. And they must be, of course, a 1, 5, 6, and a 9. But now we have a 5 in one of these two squares, and we have a 3 here. We have a 5 here and a 3 here. So a 5 and a 3 must go up here along with a 2. And I want to look at these 3 empty squares again. There must be a 7, 9, and a 3. We got a 7 and a 3 here, so this must be a 9. And now this 9 blocks down, this blocks up, this blocks over, so here's another 9. Now we just need to find a 1, 6, and a 5 for these squares. The 5, I want to put a 5 in one of these. I want this to be a 1, 6 along with this one here, but I don't know how to manipulate that. A 7 and a 3 in these two squares. At least that's something. So let me look down here. We're looking for a 2, 4, 7, 8, 9. 2, 4, 7, 8, 9. There's a 2, 9, 4, blocking here. So this is a 7 or an 8, and there's a 2, 4, 9 blocking here. So these two have to be a 7 and an 8. Maybe we can work with that. One of these must be an 8 now, and one of these must be an 8. So 7 and 8 in these two squares. That leaves only a 4, which can't go here and can't go here, so it must go here. And a 2 and a 9. So we got 2, 9 here and 2, 9 here, a remote pair. And what's more, these being 7, 8, therefore these must be a 1 and a 5. We also seem to have a 1 or a 5 here, don't we? Because it cannot be 3, 7, 8. It could be a 1, yes, but not a 2, and of course not a 3 or a 4. It could be a 5. It cannot be a 6, and it cannot be a 7. So we got and an 8, of course not. So this is a 1, 5, and this is a 1, 5 pair. And that means that we need to find 5 for one of these 5 squares down here, and a 1 as well. So I think we need to have a 3 in this square here. Let me try to explain a unique rectangle. We know that these two squares must be a 7 and an 8. Now let's look at these squares here. They must be a 3, 7, and an 8, right? Because we have a 3, 7, and an 8 here, and a 3, 7, and an 8 here. So these squares must be a 3, 7, 8. So 3, 7, 8 here, and here is a 3 blocking over. So this is also a 7 or an 8. So now we got 1, 2, 3 squares being a 7 and an 8. And to get out of the unique rectangle issue, this square cannot be a 7 or an 8. And the third digit that we need for these 3 squares is a 3. So this square has got to be a 3. These now have to be a 7 and an 8. Now we got a 9 and a 3 here, we got a 9 and a 3 here. So a 9 and a 3 must go up here in 2 squares. We have got a 2 blocking across here, another 2 blocking across, and this 2 is blocking down. So here's a 2. I don't know how I could overlook that for so long, but we found it. Let's look again at these squares. They have to be a 2, 3, and a 5. So here's a 2, and these now have to be a 3 and a 5 pair. Now I'm still looking for a 5 for column 2. Clearly, since a 5 must go in one of these 2 squares, we need to find 5 for one of these 4 squares. These 2 5s block across, so no 5 can go here or here. And we need now a 5 for one of these 2 squares. But as we have just learned, one of these 2 squares must be a 1 and the other must be a 5. Therefore, this cannot be a 5. Therefore, a 5 must go here. And now I think I'm back to the 1, 6 pair that I was looking at earlier. Because if we look at this square and this square, they have to be 1, 6s. I worked that out earlier, but we can do this again. This could be a 1, yes, but another 2, 3, 4, 5. It could be a 6, but not a 7, 8, 9. So this is a 1 or a 6. And this here, this square is limited by the exact same digits. So it could be a 1, but not a 2, 3, 4, 5. It could be a 6, but not a 7, 8, or a 9. So we got 1, 6 here and 1, 6 here. 2 more digits to be found, namely for here and for here. And they, of course, must be a 5 and a 4. This square is blocked by this 5, so a 4 must go here and a 5 must go here. Now we got a 4 blocking down, another 4 blocking down, and 1 blocking across. So here's another 4. 4, 4. We need a 4 for up here. and this is 4 blocks. So here's a 4. And that happens to be the last 4 of this grid. So they are out of the way, out of sight, out of mind. What are we looking for here? We know this is a 1, 6. What's the third digit? A 2. Unfortunately, that could go here or here, so that will have to wait. But finding these 5s, especially this 5 here, helps me with another 5, because this 5 blocks here, this 5 blocks here and here, this 5 blocks here. So a 5 must go here, and that makes this a 3, because we do remember we had a 5-3 pair here, right? What about, can we do other 5s here? No, not yet. Here or here. Now a 1 must go in one of these 3 squares. Also not very helpful. What is helpful, however, is the realization that the 5 and a 7 block across here. So a 5 and a 7 must go here and here. And we already have 1 5 blocking up. So here's a 7 and here's a 5. And therefore this must be a 3. And that would make these squares here a 1, 9 and a 3. And therefore a 9 must go up here somewhere. What about the 1? The 1 must go up here. So a 1, 9 and a 3 here, leaving a 2, 8 and a 6 here. The 6 blocks. So here's a 6. Now this is a 2 and an 8. The 2 blocks. So here's an 8 and here's a 2. This 2 blocks down. So does this. Therefore a 2 must go here. And this 2 blocks across. So here is a 2, which blocks up, making this a 2 and this a 1. So here we just need now a 9 and a what? And a 7. And we knew that these were 2s and 9s, right? So therefore this, of course, must be the 9 and this must be the 7. Which blocks down, making one of these a 7, blocking up. So 7 must go here or here along with the 8. We knew that. So where are we at? We are at these 2 here. They must be a 1, 6 pair. The 6 blocks down. So here is a 1, here is a 6, here is a 1. 6, 6, yes, here's of course also a 6. This was a 1 or a 5. Now that we've gotten this one, it must be a 5, and therefore this must be the 1, and this must be a 5. 7, 8, 7, 8, therefore this must be a 1. And this was also a 7, 8. We have to leave that for now. But not here. Here we can do something nice. We can enter a 9. And that 9 blocks over, making this square a 9. This must be a 7, of course, and this must be an 8. Here we're looking now for a 1, 7, and a 6. And that'll have to wait as well. What about the 6s, though? A 6 blocks across and down. So here's a 6. So 6 blocking down and 6 blocking down. Here's a 6. Now a 1 and a 7 here. 1 blocks down. So 7 goes here, 1 here. This is quite a good puzzle today. 1 had to go here, and this square must be a what? A 3. Now we're looking at these 2. They have to be a 9 and an 8. The 8 blocks across. So here is a 9, here is an 8, making this an 8, and this must be a 7, and this is a 7, and this is a 7. And here we are looking for the 9, and up here the last digit has got to be a 3. And that's it for today's hard Sudoku puzzle from the New York Times. Quite an enjoyable puzzle, I have to say. Not that easy, though. I hope that you also enjoyed it and that you'll come back for more soon. Bye for now.